Hello everybody and welcome to today's webinar. Thank you for joining us early and logging in early. Sorry for the slight delay getting started. I'm sure you all saw us quickly check our screens, but I hope I gave you a nice little insight into how we get ready to kick things off. But we're now ready to go. So thank you once again for joining us. I hope those of you that were interested in the free ebook that we're giving away, Tortoise SVN and Subversion Cookbook, had a chance to download it. There is a URL at the bottom of the screen, so if you didn't get a chance to, then please do visit that URL at the end of the session. So just a couple of things before we get started. Everybody will be on mute for the duration of the event. Hopefully you'll be able to hear us throughout the session. Sometimes, depending on your bandwidth, you might lose a little bit of sound every now and again. Obviously, if you lose sound for an extended amount of time, please first check your own audio settings, and of course do let us know because something might have happened our end. There will be a Q&A session at the end of the main presentation. But please do feel free to ask your questions in advance, particularly as Cary goes through the topic and hits upon things that you'd like a little bit more explanation of. We won't be able to answer the questions until the end, but please, as I said, do feel free to ask your questions in advance using the chat panel on your GoToWebinar console. So today's session is Performance is a Feature. Here is the specification, and the main presenter today will be Cary Millsap. So as always, I'm James Mercer. For those of you that came to the last webinar, which was last week, you would have seen this photograph, but I thought it was quite a nice way of sort of showing you where I'm talking from, particularly those of you that come to the sessions regularly. So this is actually a photo of the Redgate offices. This was taken last year on our 13th anniversary. You can see where I'm sitting in this group, and just out of interest, I'm actually talking on the ground floor in the far right-hand corner. So I'm James Mercer. I'm a part of the Oracle team at Redgate, creator of all things Oracle.com. But today's main presenter will be Cary Millsap. He's an Oracle ACE director, co-founder of the Oak Table Network, and founder of Method R Corporation. When Cary comes on the line, he will tell you a little bit more about himself. So this session is brought to you by Redgate and Source Control for Oracle. For those of you that have never come to a session before, you may not have heard about Redgate. If you haven't, then as I mentioned before, we've been around for 13 years. Over 600,000 technology professionals worldwide use Redgate software, including 93% of the Fortune 100 companies. So most of the companies that you've heard of, the big companies, will be using Redgate's products. We've spent an awful lot of our time in investing in UX and ensuring that our tools solve complex problems, but in a very easy-to-use way. If you'd like to find out a little bit more information about Redgate and our Oracle tools, then please go to redgate.com/Oracle. So for Oracle teams, we produce a number of tools which fit into the deployment suite for Oracle. So we have Schema Compare for Oracle, Data Compare for Oracle, as you can imagine, enable you to compare schema structure and table data between environments, generate a script to deploy those changes across. We also have a new product called Source Control for Oracle, which makes it a lot easier for you to source control database code. It's very easy to source control application code. You can imagine that they're just files, but source controlling database objects, there's a lot more things that you have to think about. It's traditionally a lot more tricky. So we've produced a new tool to help you do this. If that's something that you're interested in looking at a bit further, if it's a problem that you're trying to solve at the moment, please do hang around after the main presentation, and there will be a demonstration of Source Control for Oracle. as well as producing tooling for Oracle developers, SQL Server developers, .NET developers, Redgate invests a lot of time and resource in supporting the communities around the technologies that we produce tooling for. So this webinar program is part of the work that I'm doing to help the Oracle community. It's something that I believe very passionately about. It's the reason that I set up the All Things Oracle website, and it's the reason that I put on these sessions every 2 weeks. So under the redgate.com/oracle-education, you can see all the things that I'm doing to try and help you out. So the webinars, allthingsoracle.com, and free ebook offers. So please do check those out. So I think that's enough of an introduction from me. So let's get cracking with the main presentation. I'm going to hand over to Cary Millsap now. Please do bear with us as I hand things over.
That was relatively painless. Let me see. I've got one more click here. Excellent. James, thank you very much.
Thank you, Cary.
Well, good morning or good afternoon. I guess I should just say good Wednesday to everybody. I'm Cary Millsap, and for a couple of years, I've been talking about the concept of performance as a feature. And about a year ago, the idea occurred to me in kind of a flash of insight that if performance is a feature, then dadgummit, what's the spec? So I thought it would be a good presentation to put together to just tell you what I think the spec is. For a lot of people, especially folks that build and use enterprise applications based on Oracle, I think that to them, and this thinking is the result of about, I hate to say it now, but almost 30 years of experience helping people make their applications faster. My perception is that most people regard performance as sort of a necessary side effect of the applications that they build. They first think in terms of functional correctness, and of course some people struggle even to get that far. But once people have achieved functional correctness, they sort of assume that they're finished, and they sort of lean back and cross their fingers and hope that the performance is okay. And when it's not, of course, then there are all sorts of engagements of various machinery to try to go repair the performance problems. But that, to me, indicates that people think of performance as a side effect and not really a feature in and of itself. So I'm not just trying to artificially promote performance as being important, and by trying to do that, just calling it a feature and just sort of eliciting kind of a grammar trick. I really think performance is a feature, just a first-class feature, just like book and order is a feature. Being able to see, manipulate, manage, analyze performance is a feature. And this presentation is about what I mean by that. Now, I'll do a quick introduction. Thank you, James, for giving me a nice introduction at the beginning, but I want to show you a little bit about my background. I started my professional career back in 1987 writing compilers for United Technologies Microelectronics Center, and took a year off to go to school, spent 10 years at Oracle. The little stars represent times when I became kind of an executive titled person inside the companies. Left Oracle in '99 to co-found a startup that I was with for almost 10 years, and then in 2008 joined the company that I'm with now. Those of you who know me probably have met me either at a conference, at a presentation, or know me through these publications that I've written. Probably the most recognizable one is the one that I wrote back in 1994. I'm sorry, back in 2003. Excuse me, I'm going to mute myself and sneeze. So we'll be right back. Thank you, Blue Yeti, for the mute button. So most of you who've heard of me probably have met me through this O'Reilly book that I wrote back in 2003. Here we're going to sneeze again. We'll just edit that out, right? Anyway, written a few things since. Parts of this Oracle Insights book, a two-piece article for CACM, And the thing there called Mastering Oracle Trace Data, which goes late 2011, is when I wrote that, is really a course notebook for a class that I teach, which does have to do a lot with what we're going to talk about today. What most people don't know is that I wrote a book back in 1985 called Basic for the IBM PC. I think they only sold about 4 copies, so not many of you have probably seen that. But here's the span of when I say almost 30 years, it's what I mean. One thing I want to do before we get too deep is I want to thank James and the whole team at Redgate for the opportunity to do this kind of a session. And not just thank you for the opportunity for me to do it, but also for some really good stuff that links in very well. And one in particular that I want to mention, and I see that he's on the call as well, but a few weeks ago, Lasse Jensen did a presentation called End-to-End Metrics, Building a Performance Bridge Between the Developer and DBA. And I highly recommend that you go see that. Go look it up on the allthingsoracle.com website and have a look. What I'm going to talk about today is, I think, a very logical mesh with what he was presenting, and it warms my heart to see that the subject matter is important, not just to me, but to other people out there as well. So thank you, Lasse, for some inspiration in helping me sort of connect this to a wider body of work out in the marketplace that you're participating in. So let's get underway. This is a presentation about performance, and I don't like to use words in presentations before I make sure that everybody understands the word the same way that I intend it. So before we go too much farther, I want to just show a definition of what performance is in the context I'm going to be speaking in today. And that'll hopefully make sure that we sort of are all focused in on the same exact thing that I mean when I say the word performance. And I think this is the most important thing I can say about it. Performance is not an attribute of a system. Performance is an attribute of each individual experience with a system. And I've got a little proof of that I'd like to run past you here. What I want you to do is imagine responding to this particular declaration. Describe your system's performance. And if you do that, I want you to think, is your system always either fast for everybody or slow for everybody? And the answer to that is probably no. It's probably fast on some days, slow on some other days. Maybe fast for some people, slow for other people. Maybe it's fast for some clicks in some applications, but slow for other clicks in other applications. And if you think about what that means, it adds up to what I had on the prior slide. That performance is not an attribute of a system. It's not if you think about an entity relationship diagram of what performance is, and that's what we're going to get to, it's not a binary attribute, fast or slow, that gets attached to the name of your host. It's an attribute of individual experiences. It might be that a user runs the same report 10 times in a day, the exact same report with the exact same input parameters. And maybe that experience is fast, 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 slow, fast, 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 and fast. Well, performance is not even an attribute of that report. It's an attribute of an individual execution of that report. So what performance is to people who use systems day in and out is simply this: my thing has to finish quickly. And your thing might be a click or a row in a forms application or a query that you run or a batch job that runs overnight. That's what performance is that your thing has to finish quickly. So how do you know when your user's thing is fast? And I presume that probably most people on this call, just because it seems to be the type of audience I generally attract, but I assume that most of you are probably database administrators or application software developers. And James, if you get bored while you're hearing this presentation, it might be interesting if you just put together a binary poll, or actually a three-way poll, and just ask, are you a DBA, a developer, or something else? That would be interesting information for me to have. But imagine that you're running a system or writing a system. How do you know what the users are feeling? I mean, do you have to feel it yourself? Do you actually have to run a function that you've written or a function that you manage and see if it's fast or not? Do you have to experience it firsthand? Do you have to walk up behind somebody and watch somebody execute a report that you wrote 6 months ago or that you're responsible for providing high performance to? Do you really have to walk around all the time to be able to tell if your system is fast? Do you have to go to the cafeteria and listen to people talk about whether the system is fast? Do you have to constantly poll people through telephone calls? Hey, is it okay today? And as I mentioned on the prior page, the answer is complicated. The answer might be yes, 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 no, yes, 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 and yes. And you've got to get down to the bottom of where did that no come from? Is it a particular report that ran at 10:14 yesterday? Did it have different input arguments than the other reports that were run? Did it have different load that was running at the same time the report was run? Is it somehow it ran before a critical statistics collection process took place? You need to know a lot more detail than you can possibly find out by looking around or asking people questions all the time. So how do you know when your user's thing is fast? Do you have to feel it? It would be better if you could look it up. And really the question that we want to know is what have people been experiencing? And that ends up being the feature that I'm talking about. What we want is an application that can tell us what people have been experiencing. That's the feature that we're going to talk about for the remainder of today. So let's move into Chapter 2. How do you measure that? How do you measure what have people been experiencing? And it boils down to the fact that people feel performance in two ways. There are really two key performance questions, and these are the only two. I mean, basically everything I've ever heard in almost 30 years of working on performance problems can boil down to one of two expressions. Either how long does it take to do this thing, or how many of these things can we possibly do? The first question, the how long does it take question, is typically a question that users ask. I hate this thing because to get a book order confirmation ID, it takes me 14 seconds, and it should take less than 2 seconds because the last company I was at, it was so much faster than it was here, and I'm constantly frustrated here. The second question is typically a question that managers of departments ask. If you're managing an order entry team of 20 order entry clerks that take phone calls and type in orders, you're going to have to manage to things like how many orders a day does this team have to process in order to meet our goals? So you need to know how much stuff can this system do. And of course, stuff is clicks, buttons, links, rows, queries, reports, and batch jobs. Now these two ways of looking at the world have names. The how long does it take question is called response time, and it's the duration from service request to service fulfillment. And the picture on the left represents different users' timelines as they experience different things throughout their day. So if you imagine that time flows from the top of this graphic on the left to the bottom of the graphic on the left, then you can see that Sanjay at time t0 has initiated a request, and this red code path runs. And when his request is completed, I draw an upwards pointing triangle at time t1, and his response time is the difference between t1 and t0. So it's really easy to calculate if you know when the request was made and when the request was fulfilled. On the right-hand side of the page, you can see that the how much stuff can we do question is technically referred to as throughput, which the mathematicians refer to by the letter X. And throughput is simply a count of service fulfillments within a given time interval. So if we pick a time interval that I've called T here, and if I want to focus, say, only on the green code path, maybe the red code path is pick an order, but the green code path is book an order, and we're interested in book order throughput for the given interval T, then I can tell you that book order has had one completion and then a second completion. So the throughput is completions divided by time, and there were two green completions in this time interval. So the throughput on the right-hand side is two triangles per T. Now, as it turns out, if you know when a request was submitted and when each request was fulfilled, you can compute both response time and throughput. Because as you can see on the prior page, to know R, you need to know T1 and T0. And to know X, if you just know the T1s, you can calculate X. So the key is you need to record those times. You need to record when requests are issued, and you need to record when requests are fulfilled. And you need a few other things as well, and we'll get into that. Now, a fair question to ask is, if you do this, what do you get? And it's really important not to lose sight of the original question that we're trying to incorporate into our applications as a feature. We want the feature of being able to know what have people been experiencing. So the rest of this chapter, I'm going to show us a sequence of cases, of tickets that you would log into a feature tracking system. So case one is the case, how long do people wait for their stuff? And what I mean by that is I want to be able to show response time for any user experience that was executed within the past, say, for example, 5 years. Now, how do I want this information presented to me? Well, kind of an obvious way would look something like this. We've got a table that has 5 attributes in it. It's got a username, so we can tell who we're talking about. We have an IP address, so we can tell where the person is that's doing the thing that's getting executed. We have a task name, which names the thing that's being done. We have a time requested, which this is an ISO 8601 date time formatted string. You can see that it's the year 2012, the month 9, day 4, and the time was 14/22/08. And then we could either have a column that's the time of completion, or which a thing that probably people are more interested in seeing is, what is the response time for this request that was made at the time in the time requested column. So you can see how long each individual experience took. And you can see that Nancy shipped an order at 14/22, and Ron booked an order at 14/22/12, and Ken picked an order at 14/22/18. So every single experience that gets executed on the system, I'm persisting a little bit of information about those experiences in a table. Now, the next question you're probably asking is, where do you get this stuff? And the answer is, it takes participation from the people that develop the application. Now, there are tricky ways that you can embed this stuff deep inside frameworks so that the developer of an individual function never has to even know that it exists. But if you don't have a framework like that, then the developer can easily collect the data that I've shown in the prior table by doing the things shown on this page. So, for example, inside of Oracle, let's imagine that your book order code is in this comment. So where it says your book order code path goes here with a green bubble next to it, that's the code that a developer would normally write to book an order. But before that book order, there are 5 lines of code. At the top, we're calculating a username using the sys_context function call that comes with Oracle. The argument user env and session user, the 2 strings passed in, will give you a username as a function returned from the sys_context function call. The IP address does the obvious thing. We're looking in the user env table for the IP address attribute. And those things come from Oracle, so that's why we have a red dot labeled Oracle function. The next line, called task name, is something that a developer has to basically label his code path with. And it's really important that the task name be something that maps to customer land reality. If a customer comes into a meeting and says, I hate it when I book an order, the last thing you want is for the name of this task to be called something other than book order. You don't want it to be called X4G776 unless that's what the user calls it. Basically, this task name is a join column that allows you, when you hear a user complain about something, to know exactly which code path that user is talking about. The experience ID, which you can get, for example, from Java using the random UUID function call, I'll describe a little later. I want to add that in after we get a few things established. The T0 is simply a timer call that says, what time is it before book order runs? And T1 is another timer call that asks the question, what time is it after book order runs? Of course, if you subtract T1 minus T0, you get the response time of the book order code path. And then finally at the end here, something that you have to write yourself is something that persists the data that we've collected, the username, the IP address, the task name, the experience ID, T0 and T1, to some place. It could be a log file, it could be a database, it could be a shared memory segment, but it has to be stored somewhere in order for us to be able to produce the table that's shown here. So having seen where this stuff comes from, it's really easy to understand, well, this is where the IP address comes from. And of course, the only derived column in this table is the R column. which is computed by taking T1 minus T0 for a given experience. So that's easy. Now we've got a table with potentially trillions of rows in it. Now what are we going to do? Well, the next ticket in the performance as a feature set is, well, how long do tasks take? Now, I wanted to define what a task is, and you got a clue. I'm going to page back 2 pages. When we have an entity called a task name, it kind of leads you to understand that a task is a piece of code path. When somebody executes book order, what I call book order is, as say book order is the task that's being executed, and the individual execution of book order results in an experience which has attributes, a start time and an end time, for example. So a task is really a piece of code path, and I'm asking the question in case 2 here, how long does my code path take? And in the description I say, well, I really want to see response time grouped by task. So the output of that might look like this. Ship order, on average, takes 2.084 seconds. Pick order takes, on average, 1.260 seconds. And book order takes, on average, 0.353 seconds. Now, the mean column is what people typically think about first when they think in terms of how am I going to report performance, response time performance in particular, back to a questioner who's asking me how long does ship order take. I can say ship order takes on average 2.084 seconds. But averages, other measures of central tendency, don't really tell you as much of the story as the second column that I've added here that's labeled R to 99%. What this is, this 9.597 number, is the 99th percentile ship order response time. Now, those of you who've had babies and taken them to the doctor, and the doctor tells you your son is in the 76th percentile by height and the 48th percentile by weight, what that's saying is that your baby is as tall as 76% of babies that have been measured, that 24% of babies are taller than your baby. What this 9.597 number means is that 99% of executions of ship order have taken 9.597 seconds or less. In other words, 1% of ship order executions have taken more than 9.597 seconds. So this column is really convenient because it explains a lot more than the mean explains. And it also is the way that a lot of people like to express their service level agreements. Service providers can tell service consumers, look, I promise that at least 95% of executions will respond in less than 2 seconds, for example. That's a way that people specify performance tolerances. So what this page says is that 99% of book order experiences, the third row on the table, are better than 1.626%, or in other words, that 1% of book order experiences are worse. The question that this leads to is, okay, well, which response times exceed our tolerances? So what that means is I want to store a performance tolerance for each task, and I want to compare each response time to its tolerance. So an example of an English sentence that I'm referring to here is to say, for example, that our experiences, for example, for book order, must not exceed 2 seconds more often than 1 time in 100. And it turns out mathematically that that's true if and only if the 99th percentile response time is less than or equal to 2 seconds. So it's easy. And the nice thing about storing your performance data in, for example, an Oracle database is Oracle has an analytic function called NTILE, NTILE, which will actually allow you to report, given the table that I showed you before, on what is the 99th percentile of this column in this particular table. So if we have a response time column, all we have to do is use the NTILE function to figure out what our 53rd percentile or 95th percentile or 99th percentile number is. So we can have a table that looks like this, and I've simply augmented what I showed before. We had a 9.597 99th percentile response time for ship order before. Imagine that our tolerance for ship order is that 99% of the time we are supposed to be able to ship an order in less than 5 seconds. But what we're seeing here is that we're violating that tolerance. So let me read these column headers again really quickly. What this is saying is that I'm tolerant of ship order only if 99% of the time it takes 5 seconds or less. But what's happening in reality is that 99% of the time my ship order is taking 9.5 seconds or less, which is nearly twice what I'm supposed to be getting. Now in this third column here, the third attribute column, labeled percent of experiences that exceed the tolerance, well, what I want here is a number that's no bigger than 1%, because I want no more than 1% of my ship orders to exceed 5 seconds. But actually what's happening is that instead of ticking people off 1% of the time, I'm ticking people off 8% of the time. Now they're willing to be upset 1% of the time, but I'm exceeding that by a factor of 8 with regard to ship order. Now pick order is a little bit better behaved. It is violating the 5-second tolerance only 9 times out of 1,000. And book order is in great shape. It's only violating our 2-second tolerance 0.7 times out of 100, or 7 times out of 1,000. Whereas we would be permitted to violate that tolerance 1 time out of 100. So we can actually shade these cell values, red, yellow, green, depending upon whether we're meeting a service level requirement or not. So in this particular case, ship order is just not meeting our service level objective. Now, some people like tabular data. I do, because it gets me closer to what I consider to be the truth. But when you start looking at lots and lots and lots of tabular data, the brain can't parse it quickly enough. And we need to move the analysis from the reading part of our brain to the visual cortex part of our brain. And here's a graph that you might consider. This is a graph that shows response time expectation violations, so the number of, or the percentage of the time that we're violating people's expectations by task. What I'm showing here is ship order, and I've grouped by hourly time buckets. So you can see, for example, that 8 in the morning, we're only violating expectations about 0.5% of the time. At 9 o'clock, we're doing even better than that because this bar is shorter. But at 10 o'clock, we're violating expectations almost 10 times out of 100. Almost 10% of the time, people's expectation of how long this thing should run is being violated. And we're having a really hard time from 10 to 11. Even at noon it gets better, but we're still violating people's expectations 3 out of 100 times as opposed to the 1 out of 100 that we promised them. So we can see here that we're having a really rough patch during pretty much all the business hours between 10 a.m. and 5 p.m. So pictures like this make performance easier to see for people. Now the next question that's interesting to ask is, all right, maybe I've got a task that, maybe all my tasks are meeting our expectations today. But I'd like to know, when's the next one going to break? What I want to do is compute when a 99th percentile response time for a task is expected to start violating its tolerance. And a picture here is really helpful. This picture shows that in January, we only violated expectations about 0.4% of the time. In February, maybe 0.45% of the time. In March, we violated expectations about 0.5% of the time. So in other words, what you can see here is a stepping towards oblivion, right? We're allowed to exceed people's expectations in one experience out of every 100. And what's happening is we're meeting the goals, but clearly we're on a progression here where if the clock keeps ticking forward and something doesn't change, sometime around October, and you can see by this blue line, which is sort of interpolating where this progression is going to pass this red 1% bar, sometime in October, we're going to start having problems. We're going to start violating expectations more often than we are permitted to. And so what we've got here is kind of a forward-looking radar that says, look, we've got about 3.5 months to fix whatever it is that's causing book orders response times to ramp up like this. Now, if you like tables, you can express this data tabularly as well. And let me start at the bottom in the good news land. Book order here you can see has a 2-second tolerance, and the 99th percentile response time is less than that, so that's good news. And the percentage of experiences that exceed our tolerance is only 0.7%, and that's good news because we're permitted to exceed them 1.0% of the time, so we're doing better than that. But the estimated days until my response time exceeds my tolerance can be calculated using this linear regression technique I showed on the prior page. And in this particular case, we have 117 days to fix a process that's not currently broken with respect to causing people pain, but we can predict very accurately when it's going to start causing people pain. And you can see up here at the worst extreme that, well, ship order is already violating people's tolerances, so we have no predicted future date. We're already in the red zone. Pick order has a much shorter leash. We only have about 2.5 weeks before pick order is going to start violating the 5-second response time more than 1% of the time. So pick order is on an 18-day collision course. The next question is, we've got this one user who keeps complaining. And when we talk to users who complain, it's usually difficult to know, is this person really just super sensitive or particularly difficult to please? Or is this person actually noticing something that's distinct behavior that none of the other users are experiencing? And this is a hard one to get because there's so much subjectivity involved. If you sit down with a group of users and 4 of them are happy and 1 of them is bitter, it becomes kind of a psychological puzzle almost to figure out, well, what's with this person? Does she just like to complain, or are things really worse for this person than they are for everybody else? Well, that shouldn't be something that you have to measure subjectively. You should be able to measure that absolutely objectively. And a way we can do that is simply by grouping by task name and username. And in this table, we can see that there are lots of people who ship orders. Nancy, Ron, Ken, and Harold all ship orders. And they all have the same tolerance. You could design your system so that you've got different tolerances for different users. But these users all have the same tolerance. They're all happy if we can hit 5 seconds or less 99% of the time. But Nancy's expectations are being violated 18% of the time. 1 out of every 5 times she runs this thing, it takes longer than 5 seconds. Whereas Ron only has his expectations violated less than 1 time in 100. Ken's even better, and Harold's even better than that. So yeah, in this particular situation, Nancy, whether she's a complainer or not doesn't matter. This set of data is completely objective. She's got performance problems that are almost 20 times worse than anybody else who does the ship order task execution. So Nancy's ship orders really do take longer. Now the next question I'd like to be able to ask, and realize every single question that I've answered so far, cases 2, 3, 4, and 5, have all needed only the data that we stored in case 1. Username, IP address, task name, a tolerance. I didn't show the tolerance in case 1, but a tolerance and a start time and an end time, and that's all you need in order to answer all these questions. Now we haven't used the IP address thing yet, but we're going to in this next case, because the next thing I'd like to know is it just Nancy, or is it a whole subnetwork? Is it a whole division? Is it a whole room full of people that Nancy represents, or is it just her? So what I'd like to do is show response time group by task and subnetwork. So that's pretty easy, actually. I can group by task, and then I'm just going to peel off, I'm going to peel off the last segment of the IP address. So I don't care about the difference between 192.164.1.101 and .102. I'm just going to group all the 192.164.1s into one bucket and see how the performance is doing for ship order. And what we see here is that ship order for everybody at 192.164.1 is nearly 13 times worse, or more than 13 times worse actually, than every other IP subnetwork that we serve with ship order task service. So everybody, for example, in this case, everybody in Atlanta is suffering. So all these things are expressions of what have people been experiencing. You can see the direction that this is going. There are hundreds of ideas that can be explored, and the kinds of things that managers want to know can be answered by these very simple attributes that can be collected very easily by developers every time a task is executed. So the important thing is what you measure. And if you notice, this whole presentation so far is about measuring experiences, the things that people feel. It's not been about measuring resources. Nowhere in this conversation have I mentioned how busy is the CPU, how busy are the disks, how many times do we hit on a latch or miss on a latch. Those are important on other dimensions, but if you're trying to figure out what people are feeling, I don't care about latches and CPU and disk I/O at this point. So what we need to measure is experiences that people feel, not just the resources that are being consumed while they feel things. Now this leads us into one of the final chapters called the traceable experience feature. Now so far what we've been able to do is determine if Nancy, for example, has something that runs longer than Samir's thing. So we can tell objectively whether Nancy's having a harder time than the other users on the system. But the $64 question that remains unanswered by knowing that is this one. Why did her thing take longer than the other thing? So to answer that, what I'd like to be able to see is response time grouped call by call. Well, I want to see response time call by call grouped by the individual experiences that take place. So if Nancy's thing took 30 seconds, I want to be able to see exactly where all 30 of those seconds went. If Samir's thing took 2 seconds, then I want to answer the question, why did Nancy's thing take 28 seconds that Samir's didn't take? So what I want to be able to do is drill in and see exactly what code path did she run as opposed to what code path did Samir run. Because there's 28 seconds in Nancy's that didn't exist in Samir's, and I want to be able to find it. So the first thing we have to answer in order to be able to do this is how do we distinguish one end user experience from another? And in Oracle, we have 3 fields that are associated with any database call: parses, execs, fetches, and all the other things that databases do for their clients. And in Oracle, these 3 fields are called module, action, and client ID. And one convention that you could adopt is to set your module to the application name, set your action to the task name, and set your client ID to the 3 fields that we need to keep in order to keep track of this stuff. Now you've seen the username and the IP address, and I'm going to introduce this concept of a universally unique ID in a moment that you'll understand when I show you the table that we get as a result. Now the way to set these things, if you're using PL SQL, is you use dbms application info.setModule to set the module and the action. To set the client ID, you use the function dbms session.setIdentifier. If you're using Java, it's easier. You simply use a method called setEnd-to-End-Metrics, which has been available since Oracle 10, and it's one of the things that Lasse Jensen talked about in his presentation back in May that I recommend that you go see. So it's reasonably easy to do. In fact, I'd say it's extremely easy to do. If you bother, here's what you get. You get hooks into your $V data to group by. If you're a DBA, that's important to you because DBAs look at $V fixed views all the time. For example, in $V session, you'll notice that there's a module, action, and client identifier column in this fixed view. And when you set these things, these values show up in $V session. They show up in a variety of other $V tables as well. If you're a developer, you probably couldn't care less about that. But if you're a DBA, that's important. If you run Oracle Enterprise Manager on an uninstrumented application, you probably get a lot of pie charts that look like this one. We've got 100% of our top clients are unnamed, and there's no information whatsoever inside this pie diagram. Well, there is information. The information is nobody instrumented this application. What you'd rather see is some breakdown, some groupability of your applications because of how they're instrumented. So here we can see that order entry is consuming 20.6% of some resource, and HR is consuming 20.6% of some resource, and Scott's consuming 17.6%, and 41% of our application workload has not been instrumented. So you want the thing on the right, and you hate the thing on the left. If you do this instrumentation, you get the thing on the right. I think it's even more important that you can control tracing, because tracing is what's going to get us to the destination that the ticket talked about. I want to be able to see individual calls being made by the application and the database And if we have the module name and the action name set, then we can use these functions, dbms monitor.service module action trace enable. And we provided a service name, a module name, an action name, and some other things if we want to. Or we can trace, if we know a client ID, we can say, hey, turn on tracing just for this one client ID by using dbms monitor.clientID trace enable. Now if you do that, you end up getting hooks inside your trace data that you can group by. So this is a little excerpt of what trace data looks like. Inside of a trace file, these lines that begin with 3 asterisks appear, and if you've set your client ID to the thing in blue, then that client ID is actually going to show up inside your trace file. If you set your module name and your action name to the values that are set here in blue, then you're going to actually see them inside your trace file as well. And all of the database calls and operating system calls that the Oracle database is going to make are going to occur after this paragraph, and whenever somebody else executes a different experience, there's going to be a new stanza of these 4 lines which will kind of label the trace data that will follow those. So inside of a trace file, we can actually see which calls went with which experiences because Oracle documents inside the trace data any of the experience identification information that you've bothered to put into it. So if we use that information, here's the kind of stuff that your trace files can tell you. I'm going to let you absorb this report for just a second. What this is a report that gives response time in the duration column, grouped by experience ID, username, and IP address, module, and action. So this is one gigantic column. And this experience ID is the UUID that I told you earlier that I wanted you to collect, but I didn't tell you why. Well, now you know why. If we can assign a unique ID for every execution of every task that takes place on our system, then we have an attribute that we can group by that will tell us how long did that experience take. So this is literally a line that says that Nancy Phelps at IP address 10.17.22.12 did an OE book, and that unique experience, whose ID is EEC4C blah 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 C6F, took 49.699960 seconds. And there's some other attributes in this table that I've truncated and didn't show you. Now this table is produced by software that we write that eats a whole directory full of trace files and tells me Nancy Phelps just booked an order and it took 49 seconds. Vern Saunders just booked an order, it took 48.9 seconds. Paul Drake just booked an order, it took 47.52 seconds. And you can see that these things are sorted in descending order of duration. These are actual experiences that people have felt, and if I call Nancy and say, hey Nancy, you just booked an order, didn't you? She'll say yes. You can say, it took almost a minute, didn't it? And she'll say yes. Finally, somebody's listening to me. My stuff sucks. I hate this thing. So what I'd like to be able to do with this information is to drill into that one experience, Nancy's 49-second experience, and ask the question, where did her time go? Why did her thing take 49 seconds when Lily Dillard's down here only took 28.02 seconds? Well, that's an OE ship, so it's an apple-oranges comparison. But you understand what I'm asking. So on the next page, what I'm going to do, I want you to remember this 49.699960 number because it's going to show up at the bottom of the next page. So 49.699960. At the bottom of the duration column, you can see the 49.699960 number. The numbers above it all add to that. And this is an explanation of where Nancy's program spent its time. It spent its time doing 40.5 seconds worth of SQLnet message from client calls, 18,585 of them. And that's where 81.5% of her time went. Now, this is one of the places where I get really frustrated with ASH and AWR and ADDM and OEM and all of the Oracle VDOLR-based stuff. Those things all interpret this call, SQLnet message from client, as a so-called idle event. In other words, they throw this information away. But what I've just shown you is that when Nancy waited almost 50 seconds for her book order to take place, 40 of those seconds were caused by this function called SQLnet message from client. I can do one of two things. I can call Nancy and say, hey, Nancy, I've got great news. You're waiting 40 seconds for an idle event, so you should be happy about that. That's not going to work because Nancy's waiting 40 seconds for something, and she's looking at you for an explanation of why am I waiting so long for this thing that you're calling this weird name. So we have to figure out, why is my code calling this thing 18,585 times? And in order to know that, we have to know what SQLnet message from client is. Well, fortunately, SQLnet message from client is simple to understand. It's basically the time that Oracle spends blocked on a read call from its client. So the Oracle database blocked on a read call from its client 18,585 times, and you need to understand when that happens. Oracle blocks on a read call from its client right after it completes a database call. So if you ask Oracle to fetch a row, it'll return that row to you, and then it will read from the socket that you're connected to it with until you tell it what to do next. And if you say fetch another row, it will. It will send you the other row, and then it'll block on another read. And the total cumulative duration of all 18,585 times it did that was 81% of this 49.699960 seconds. I can look at the trace data for Nancy another way. And by the way, this table is generated by basically ignoring all trace data that doesn't correspond to this experience ID, EC, 4C, 72F, blah, blah, blah. Now I can drill down further into the SQLnet message from client. I might want to know, how long did these individual 18,585 calls take? I can see that the average was about 2 milliseconds, but I can see that the worst call took 220 milliseconds. How many calls took 220 milliseconds? Well, I can group by that stuff because the data are all in the trace file. Again, this is a report that's printed out by software that we wrote at Method R, but it's all inside the trace data for you to harvest however you'd like to. So this report is telling me that there were 13,947 calls if you look on row 4. 13,947 of these SQLnet message from client calls that took between 100 microseconds and 1 millisecond. And that's about 20% of our time. If I skip down to row 6, you can see that 793 calls accounted for about 50% of our time. But those calls aren't too long. They're between 10 milliseconds and 100 milliseconds. They're not horrible network I/O latencies by any stretch of the imagination. But this is where that 40.5 seconds went that was described in the top row of this report. Next thing I might want to know is which SQL IDs do these particular calls map to? And the answer is all but one of them map to the SQL whose ID was 6M3A, 3V, 3Y, JV, ABH. Well, that's interesting. That means that there's one SQL statement that's doing something funny that's causing all of these network round trips to occur. The next thing I might want to do is ask, well, how many rows are being manipulated by each database call? It's all in the trace data. So I can see, for example, that fetch calls returned 18,378 rows in total for Nancy. And I can see how many fetch calls there were. There were 18,583. I don't want to make you seasick, but I want you to remember 18,583. That's this number here on the fetch row. There were 18,583 fetches on row 3 of this report that took 2.3 seconds. Well, those fetches returned 18,378 rows. The average number of rows per fetch is 1. The minimum number of rows per fetch is 0. And the maximum number of rows per fetch is this red number 1. So what's happening here is that we're fetching a large number of rows one at a time. And that's an application coding problem. It's not a SQL coding problem. The SQL's fine. The application, though, is asking for one row at a time from the Oracle database. And every single row is causing a network round trip. And that is the cause of Nancy having to wait 40 seconds for her data in her book order. So as an example, we can drill all the way down to the individual database call if we want to, all the way down to the individual fetch size if we want to, and know why did something take the time that it took. And this is my reason that I am so infatuated with trace data, because there's no other data source in Oracle that allows me to see my problems in such vivid detail. To conclude, and we're just about at the 11 o'clock Central USA time mark, so I'm right about on schedule, I guess. To conclude, I hope I've convinced you that performance is about measuring experiences. That's the thing that counts. How long does it take when Nancy clicks this button? And of course, I didn't spend much time talking about throughput, but I told you early in the slideshow that you can calculate throughput simply by counting how many T1s fall within a given time interval. So even though I focus more on response time, because that is primarily where we go to solve performance problems, everything I've talked about applies to throughput as well. But performance is really only one of two types of experiences. It's either a response time experience or it's a throughput experience. You can write applications that make it very easy to know what performance people have been experiencing. And you can also retrofit existing apps as well. I haven't talked about it much, but with triggers, virtually anything is possible. With modules that you can plug into application middle tiers, virtually anything is possible. I talked at the beginning about an entity relationship diagram expressing what performance is. And a lot of people in the database universe, especially in the Oracle ecosystem, believe that performance is really all about SQL. And SQL has these attributes. It has a SQL ID, and it has an execution plan, and it has a individual executions of SQL at start times and end times. But people that focus on SQL kind of see the world as an entity relationship diagram that looks like this. And the manifestation of this ERD that I'm showing right now in reality is the top 10 reports at the top of StatsPack and AWR reports. Things that show you what your top SQL is, that's really, this ERD is what those things are representing. But what I want you to realize is that there's a more encompassing ERD that's closer to the truth of what performance requirements you have if you add an entity of the task. And a task can be identified by a module and action, and a task may consist of more than one SQL statement. I mean, if I say book an order, that's not necessarily just one insert. It might be a lot of selects, it might be an update, and it might end at an insert. So maybe your task has far more than one SQL statement in it. So what I want to be able to do is group these SQL statements together so that I can map them into an individual experience that people have. I don't want Nancy saying it hurts when I book an order and me automatically assuming that one out of book order's 37 SQL statements has to be the problem. In the problem that I showed you before, it really wasn't even a SQL statement that was a problem. It was the stuff that was happening between executions of database calls within a SQL statement. So this is a little more representative of truth. But the true representation of the truth is this. Performance is an attribute of individual experiences. So what I need is a list of those experiences persisted in tables so that I can go assess them. And an experience is identified by an experience ID. That's unique, by the way, the experience ID. But I also like to be able to label it with a username and an IP address. I want to know the time the experience started, and I want to know the time the experience ended. And there are a few other attributes I might want to know as well. But this is the real performance as a feature ERD. We want to measure individual experiences, and we want to persist those someplace. So performance is a feature. Last thing I'll say before I open it back up to James for questions is that every single thing you've seen today is possible, I know, because we've already built it. So everything that you've seen, if you're interested and want to shortcut the process, we've done it. We have tools that create the reports that I've shown you. We have tools that collect the data that I've shown you. We have tools that do that linear regression thing that I showed you. So if you're interested in those things from a business perspective, please don't hesitate to give me a shout. You can reach me at cary.millsap@methodr.com. Twitter handle is @CaryMillsap. You can always reach me through James, and lots of ways to get a hold of me. Last thing, and this is just for you to look up later, if you're interested in this subject matter, I encourage you to read these things as well. James will have these in the slides that I give him. I'll give him a PDF when we're done here. So at this point, thank you for your patience in listening to my voice for a solid hour. And James, I'm going to go black and give the screen back to you. I can leave one of my slides up if you want me to, so it's a little more interesting. But at this point, I'll open the floor for questions.
Thank you, Cary. Thank you so much. And while we're just waiting for some questions to come in, I also want to kind of scan down the questions that have already come in. Cary, I did put together a poll, so let's launch this poll here. So,
oh, good.
This poll is if you could hang on, it'd be great to understand which of the following best describes your job role. I'm just going to launch that now, so it'll pop up on your screen.
Lots of DBAs, huh? So it's looking like about almost 2/3 of the audience are DBAs, and about a little less than 1/3 are database developers. If we add up database and application developers together, it's about 1/3 of our audience. And thanks for responding. I think more than 3/4 of the attendees voting means everybody's still awake, so I'm very grateful for that.
Absolutely, it's always good to see that when responses come in so quickly. So thank you everybody for putting a response in. We've got a few questions that have already come in. If you want to ask Cary a question based on this presentation, now's your chance. Please do put a question into the question panel to Cary.
Yeah, let's see. Yeah, James, if I can, I've got the question panel open. I can answer a couple of these if you want me to.
Okay, I think I'm going to close the poll in a couple of seconds. So let's close that, just put those results up on the screen, and then we can go through the questions.
Very good. And I see a nice little flow of questions here. So if you don't mind, I'm going to read a couple of them and then start answering. Let's see. I'm trying to make the question field wider so I can see the whole thing. Okay, Eric Olson asked, can you use the module action client ID tags with, say, a web application that uses connection pooling? Seems like you'd be tracing back to the pooled connection rather than the individual user. And the answer to that is if the application developer does this experience ID thing that I've suggested, then you get exactly, if you remember the table that I showed that has the 49.699960 second experience at the top, that table was actually generated from a set of trace files that were themselves generated on a connection pooling system. So it absolutely works. It is the holy grail, period, end of story for connection pool systems. The trick is that you have to set a unique identifier for each individual user experience down at the application code level. But it does work through the connection pool multiplexing. The next question that followed that from Charles Hudson was, why is Nancy the only one experiencing this issue? And in the example that I showed here, in this particular case, Nancy was the only one experiencing, well, she wasn't the only one experiencing this issue because there were about 6 different people that had 40+ second response times for this book order. In this case, the people that were having the worst response times were the people that were returning the most rows in their book order process. So presumably these are orders that have larger numbers of order lines, for example. So in their case, it was because of the particular, I'll call it the input parameters to the execution that was being run. But it points to the fact that there was an inefficiency built into how the book order process was working. So probably everybody was experiencing a little longer response times than they should, but the problem was magnified for the people who booked orders that had large numbers of rows in their booking. So the fix that I would recommend, and that I kind of implied but never said, is if we set the array fetch size in her case, or in this book order case that I showed Nancy having a problem with, if we just set that to 10 or maybe 100, the response time is probably going to drop from 40 seconds down to something less than 4 or 5. and it'll have a similar impact for people that have big orders. It'll have some impact, but not as much impact for people that have small orders. Jeffrey Zollers asked the question, it seems that this method requires tracing every session in the app, and that would be a significant overhead to the application code in the database. And the answer to that is if you did trace everything, it would create a significant overhead. And I'm not recommending that we trace everything. One of the things that you have an opportunity to do is sample with tracing. You don't have to trace everybody's everything that ever runs, but imagine that we have a table that says book order, I want to trace 1 out of every 100 book orders. Ship order, I want to trace 3 out of every 100 ship orders. And imagine that every time book order runs, there's a quick lookup that says, how many of these am I supposed to trace? And if the answer is I'm supposed to trace 1 out of 100, then book order flips a random coin with a PL/SQL random number generator, which is a fast function call. Returns a number between 0 and 1. And then we can say, look, if that number that I've gotten returned is less than 0.01, then I'm going to trace. Otherwise, I'm not going to trace. So what we've done is we've established a sampling protocol that says we're going to trace on average 1 out of every 100 orders that get booked. So by the end of the day, if we've booked 10,000 orders, we're going to have about 100 orders. I hope I did the math right. We're going to have about 100 orders with trace files. And if somebody's having a problem and none of those trace files actually captured an execution that divulged a problem, then tomorrow we can say, you know what, let's trace half of the book orders. We're not going to trace everything on the system. We're not even going to trace all the book orders on the system, but we are going to trace half the book orders because we really want to catch this thing in the act of misbehaving. I could even say, look, I want to trace every book order. So we can control the granularity with which we trace so that we can keep the workload down to a sufficiently low level that it makes it practical to do, but we can maximize our chances of catching a problem in the act. Albert Spikers, and I hope I pronounced your last name right, he says, thanks, great. I assume I can find the tools on the Method R website. Yes, sir, you can. Method-R.com. Let's see. Send me your presentation, please. So, James, I presume you'll make the presentation available through the allthingsoracle.com website. I'll make sure that you have all the slides.
Absolutely, Cary. So I will be sending a follow-up email out to everybody as soon as the video is up online. I do get these up quite quickly, so hopefully that will be tomorrow. I can send that out.
And I won't slow you down. As soon as I get off the mic here, I'll send you the presentation material.
Fantastic.
Mayank Singh asked, where can I see the experience ID? And the experience ID would be something that we store, that we persist in this table that I showed as a result of case 1. And the experience ID is available to you. You can generate a unique, universally unique ID in Java by calling this UUID function call that I showed in the notes. In Oracle, in PL/SQL, you can generate a thing called a GUID, a GUID, a globally unique ID. And that'll give you, I believe, a 32-byte number that's guaranteed, well, practically guaranteed never to reproduce, you know, on any of our lifetimes or probably even the lifetimes of our grandchildren. Let's see. James, you're probably looking at the questions too. Some of these things are, I think, things I've already covered. Ray Stell asks the question, does your mastering trace book cover how to instrument things you've covered here? And the answer to that is yes. There's lots of details in that course and also in the course book. Jason Bukata asks, how well do the Method R tools shown work in more of a batch job environment? What if the experiences are few but intentionally lengthy? And the answer to that is that's the easiest world to do performance analysis in, really. If you've got long-running batch jobs, we don't have to be nearly as careful or as precise in turning tracing on and off. If you've got a job that runs for 4.5 hours, then it's not going to really hurt anything if you don't instrument the app. If say you've purchased the application from a third party, if you run the thing and it takes you 1.5 minutes to find the SID and serial number for the process, You can trace the process while it's in flight from another DBA login, and then when the process is over, trace will turn itself off automatically when the session goes away. So in batch environments, everything that I've said here only gets easier. Let's see, Nelson Franco says, I'm new to the DBA position. Where can I learn, what can I read to learn more about monitoring and planning performance? I very self-servedly would point you to the methodr.com website. We've got lots of papers there that kind of give you performance from my perspective. The O'Reilly book called Optimizing Oracle Performance is a more thorough, very basic in the beginning, and it grows to a pretty complex crescendo by the end. But I would hope you would take a look at that. And there's lots of stuff. Basically anything written by Tom Kite, Jonathan Lewis. There's lots of information out there that can help you with performance issues. Let's see, several people that I'd like to thank for making very nice comments in the questions. Thank you, David and Adam in particular. How can the customer experience be measured generically without the database? And that's Mehmet Erdas. I hope I've said your name approximately correctly. The nice thing about the information I've shown you here, I've focused it for the Oracle community because it's an All Things Oracle webinar, but everything that I've said here really applies to any software you write, whether it has anything to do whatsoever with Oracle or not. All you really need is some attributes that explain what is it we're measuring, when did it start, when did it end, and give it a unique ID. The trace data is nice in Oracle because we can get the details about where the call time went, but if you're just writing a brand new Java program from scratch, the way that it is natural to instrument such an application so that you can debug performance issues later is to just keep track of time. When I call something inside my code, mark down, hey, I called something, here's what time it is, and when the return comes back, mark down what time the return came back. Syed Ahmed asked the question, did enabling the trace have an effect on database performance? And this is a question that's been very interesting over the last 20, 30 years. In general, hundreds of thousands of traces take place with no perceptible impact upon the performance of the thing being traced. If you were to turn trace on for everything all at the same time, I guarantee you would notice. I mean, the I/O competition just for writing the trace files alone would probably overwhelm your system. If you do it carefully and selectively enough, you're not going to notice a performance problem, I'd say in more than 99% of cases. There have been special circumstances
I'm sorry for the sound issue there. Hopefully that will sort itself out at the moment. It seems to just be something to do with Cary's bandwidth. Apologies again. I'll keep trying to check that. Cary, if you can hear me at the moment, you're just being, it's just caught one word and it's just repeating it over and over and over again.
Been able to hear me the whole time. Hey, have you guys been able to hear me for the last 45 seconds or so, or did I go away for a while?
Hi, Cary. What actually happened was it got caught on one word and kept repeating it over and over again.
That's exciting. Which word was it? Was it a really good word, I hope?
Not really, no.
No, I didn't figure. The question I was asking was from Syed Ahmed, did tracing and enable tracing on the database affect performance? And the short answer is generally not. unless you trace too much all at the same time. And there is a parameter called statistics level, which is an Oracle session settable parameter that if it's set to too high of a granularity, it has more impact upon the tracing measurement intrusion effect than anything else that we've seen. There are occasional Oracle bugs that cause tracing to take longer than it should, but Oracle's very responsive in making sure those get fixed quickly. So generally the answer is it's safe to trace things. My friend Robert Verhoeven says, why is it so hard to convince developers to instrument their applications? And the answer to that's really simple. It's because most developers are not held responsible for fixing those applications after they've gone live. I promise you, I mean, it's the developer in me that wants to do this, because when I develop software and other people use it, I am the person that's responsible for debugging the performance problems. And if somebody calls me up and tells me they hate me because my application that I sold them is too slow, the last thing I want is to not be able to see any detail about what the problem is. So I promise if developers are put into the support role for the applications, the instrumentation will follow, because developers are the ones that need it the most in that situation. Let's see, I'm seeing, I think we're going to get to the end of the questions here fairly quickly. Yvonne Zhang asks, in reference to the Nancy problem, if it's the code or logic to fetch records, supposedly others using the same code, and I think I explained that yes, they would be, but the problem was more pronounced on the orders that processed more rows than on the orders that processed only a few rows. Jimmy Brock asks, does .NET have a set end-to-end metrics functionality? And I don't know the answer to that, Jimmy. I think that it probably does, because it's probably based in the OCI stuff, which the .NET connectors probably have an OCI underpinning, but I don't know the answer to that off the top of my head. Let's see. Jeff Weiss asks the question, what about using the Experience ID for a COTS application like Oracle Enterprise Business, e-Business Suite, where at the DB level every connection is under the apps schema? That's a little tougher, isn't it? Because basically what we're talking about is a third-party application that doesn't follow the instrumentation regime that I've just specified, and I'd have to think about that a little bit. I don't remember if Lasse covered that in his May presentation or not, but Jeff, if you want to contact me offline, I've got some friends I can think out loud with and probably answer your question, but I don't think I can answer it well here. Let's see. Alex Wu asks, can a DBA invoke DBMS application info.set module for PL SQL using like triggers? Lots of times the DBAs can't change PL SQL application code, and the answer is yes, Alex. We've done that frequently, as a matter of fact. So write a trigger that, and this kind of goes back to Jeff's question too. With triggers, you can do things like say, if the user ID of the person that logged in is Nancy, then turn on trace, or set the module name, or set the client ID. If the application login name is always the same, like in Jeff's question in Oracle Enterprise Business Suite is, then you can look at other things, like if my IP address has this particular, first, second, and third segment numbers, then do something different than for everybody else. If the machine name is different, is this, then do something different than for everybody else. So these are that I've seen used over the last 20 years to, ever since triggers were invented, I guess, back in Oracle 7. It's been a way that you can interject your code path into somebody else's code path. So let's see. Ray Stell says, I was thinking IP version 6 might need to be considered going forward. Yeah, I agree. And I'm not sure how it changes the example, but I'll take a look at that. Nelson Franco says, I get frustrated trying to understand AWR reports. It seems to be more of an art than a science, and I will +1 that. Going back to BStat and EStat, I never understood how people could be confident in the conclusions that they would draw by looking at those data. It's like looking at the stars at night and saying, oh, I see I see a soldier with a lion skin hung over his shoulder and a club and his belt and his sword, and another person looks up at the same constellation and says, no, I see my mom's face. You can see patterns in AWR reports that are very misleading, or you can see pattern. You can basically prove anything with an AWR report is kind of how I feel about it. So I'm with you. Lasse Jensen, whom I mentioned in the presentation, said, let's see, I'm not sure I understand your question, Lasse. If I read it verbatim, I don't think it's going to sound right because I think you left out a letter somewhere. But you're talking about joining experience and ETEM by using the UUID. I think you need to contact me offline and we'll square that away. Lisa Koivu asks, can the Mastering Oracle Trace Data coursebook be bought separately if you can't attend a class? And the answer, as of right now, no, but I don't want to say no to that question forever. I just don't have a shipping, a formal high volume shipping thing, but I've got a few here. If you want to contact me offline, I'll take care of it. James Rapp asks, instead of using a UUID or a GUID, could you just use a simple sequence for the experience ID? The problem with that is if you go on a multi-tier, if you go try to instrument a multi-tier system, I think the simple sequence would work for a given tier as long as you don't end up with a wrap. Yeah, I'll leave it at that. If you use a 32-bit integer or 64-bit integer, you're going to end up wrapping, within a year or two probably, well, depending on your volume. The reason for the UUID or GUID is that you've got a truly unique ID that regardless of if you add 4 more tiers later, you won't have to worry about domain conflicts with one ID matching another ID unintentionally. Sean Oppenheimer asks, when is optimizing Oracle due for a refresh? And the answer to that is I've really done my refreshes through free papers on the MethodR website. And the Mastering Oracle Trace Data book is really, in a sense, a refresh, although Lisa has pointed up, the problem of it's not really being distributed as well as O'Reilly, for example, would have. So most of what I've written has been free, and most of the things that I've written that are free at method-r.com are follow-ons to the book. Sean asks, particularly, are there any 12C features or improvements that need to be noted? And I'll point you to, if you go to our homepage, method-r.com, and scroll all the way to the bottom, and just look for the word trace, you'll find a lot of improvements that have come up through 11.2, and honestly I haven't really seen a lot of tracing improvements in 12C. 11.2 was a big release with respect to tracing improvements, and 10.2 was, or 10.1 was as well. But all those things up through 11.2 are documented at our website for free. So Yvonne said answer suffices, and that's good, thank you. Yeah, Vijay Selvarajan says, wasn't Nancy and other folks' problem more pronounced due to a different network subnet, possibly a network lag along with large result sets? And the answer there is yes, too. Actually, in the when I did the network subnet mask thing for, I believe it was case 5 or 6 in the notes, that was made up data. The stuff at the end was actually generated by doing a test. So the two don't contradict each other, and Vijay, you're exactly right. If everything would have been real data, then exactly what you said would have been correct. And James, I think I got to the end of the questions. There may be some that I missed up at the very top, but I don't think I missed really anything.
Thank you, Cary. I was following down the questions with you. I think we did cover, or rather, you did cover everything. If there were questions in there that maybe we did miss, or that you thought of that you would have liked to have asked, please do put those questions on the All Things Oracle post. I'll send a link to that to you by email. It'll also be on the web page as well, next to where you get the video from.
Cool. Well, James, before you mute me and move on, I want to thank you again for the opportunity to be able to visit with such a large audience today, and thank you all for logging in and staying with us.
Absolutely, Cary. I was just going to say thank you, as always, for presenting the session. It's certainly a good one. I enjoyed it. The feedback that we've got come in as well, it seemed that everybody did. As I mentioned at the beginning of the session, if you're having difficulties with source controlling your database code, please do hang on the line. I'm going to show a quick demonstration of source control for Oracle. It should only take 5 or 10 minutes. So if this is something you're interested in seeing, then please do hang around. Before I do go there, again, Cary, I'd just like to thank you for presenting, and of course I'd like to thank everybody for attending today's session.
It's my pleasure.
Thank you. So I'm going to kick off the demonstration of source control for Oracle in a couple of seconds. Just give me a chance to bring my remote desktop across, please. Okay, before I go through the demonstration of the tool, I just wanted to set the scene with a couple of scenarios, really, a couple of ways that we think that you'll be working. So the first scenario I want you to keep in mind as I go through the demonstration is a team of developers all working on a shared database. As you can see from this diagram, the developers will make changes to the database. Source control for Oracle fits in between the database and your source control server. It currently supports SVN and TFS, but the product will make it easy for you to check changes into Subversion and TFS and to get changes as well. Of course, working on a shared environment, the database is always going to be up to date. As I go through the presentation, if you have questions or you're wondering about then deploying those changes from Subversion to your testing environment and then deploying them from your tests, UAT production, etc., the tool that I'd invite you to check out after that is Redgate Schema Compare for Oracle. So the tool I'm going to show you now, Source Control for Oracle, is all about making it easy for you to get changes, to check changes from the database and check those changes into Subversion or TFS. Okay, so this is the interface for Source Control for Oracle, and I've got one project here. And what we mean by a project is that I've connected a schema on my database, so the obstacle database. The schema is called Widget James, and I've connected that to my Subversion repository, and I've got a folder here called Widget. And what Source Control for Oracle is going to do, it's going to monitor the database and the source control server, and it's going to pick up any changes that I make on the database. So what it's looking at is the database in sync with the source control repository. So let's go into SQL Developer now, and let's make a couple of changes. Of course, I'm going to cheat because I want to keep this demonstration fast, so I've already got a script here, so let's run this script. Okay, so that's making a number of changes on my database. just going to minimize this screen here because what I want to show you, you should be able to see on the taskbar, we've got the source control for Oracle icon. It's now got a little red dot next to it to indicate that the database and the repository are out of sync. So I can right click on this and I can jump straight into that project that I just showed you. Okay, so you can see the screen, the source control for Oracle screen has now changed. We're in the project. The script that I just ran made these 5 changes. So it's edited a table and a package, and it's created a new table, and it's created a couple of a trigger and a sequence. The great thing is that I can look down the DDL of each of these objects and see where the differences between the database and source control lie. So obviously the 3 new objects, we've just got the creation script. For the database, there's nothing yet in source control. But for these 2 that we've edited, we've got this nice little side-by-side diff, and we can see where these objects have been changed. So this is not a particularly elaborate example. For example, this table here, we've just added a column, but I hope it gives you an idea that you could very easily scroll down and review the objects before you check them into source control. So the next part is I think, where the tool really shines, and that is to actually then check those objects into source control. You simply just need to type a message. So I've just reviewed them, and let's type a message here. Before I do that, I should point out that what I'm going to do now is I'm going to check them all in together as a group. But I could check objects in individually if I wanted to. The tool is intelligent enough to be able to pick up where there are dependencies between objects. So for example, this object here, I've clicked on that, it's saying that some of the selected objects are dependent on other objects, so I should select the reference objects as well. For the purpose of this example, however, I'm just going to check them all in together. So of course, in the real world, I would put something a little bit more useful than this, because this message will go directly into Subversion, and I'd want it to be useful so that I can look back and see why a certain change happened. So that's a great thing about source control. It doesn't just help you recall what's going on so that you can revert to a particular version if things go wrong. It also gives you context of why the database developed in a certain way over time. So let's check that change in. And those changes have now been checked into my Subversion repository. I can look at the history as well, so I can see the last thing that I've done, and also scroll through a history of all the changes that were checked in. If you remember in the diagram that I put up at the beginning, the context was that there was a group or a team of developers all working on the same database. And this is going to take the information from my Subversion account. You can see that I've been doing quite a lot of work here in checking changes in. As you can imagine, doing demonstrations. If I scroll down this list, I should hopefully find one of my colleagues as well. So we've got my colleague here, Michael. He's also checked a change in. We're working on the same database. The great thing is that I can look back and see the changes that he made. As a developer, this is useful before working on a new object. Obviously, as a DBA or as a manager, you get a really good insight into everything that's been going on the database for a particular version. So the next scenario that I want to go through is developers working in a sandbox environment. So they're all working on their own copy of the database, maybe a local copy of the database, although that's obviously going to have quite a lot of overhead, so it could be a virtualized database. They might also just be working on their own private schemas on the same shared database. But either way, they're able to make changes to their own schema and then check those changes into Subversion repository. So you see they would all be working on their own copy and again using source control for Oracle to check those changes in. The benefit of this scenario is it will enable the team to get the latest changes from the Subversion or source control repository before they start working on their objects. So what I'm going to do now is set up a new user, a new project, and try and simulate what would happen if a new member of the team wanted to get changes before they made changes to the same objects. And in fact, what I'm actually going to do is show you how you could use source control for Oracle to populate a schema in the first instance. So if you're looking to move to a more sandbox or distributed development environment, then source control for Oracle does also help you in that way. So let's sort of quickly open up this tree here. If you remember, when I was looking through the history, I had a colleague called Michael. I'm going to look at Michael's schema here. And Michael, if you can imagine, Michael's a new member to the team. We've just built the shell of his schema here. It's got no objects in it though. As you can see, if I scroll down, all of these fields, the tables, the views, indexes, they're all empty. So let's go into source control for Oracle. Let's set up a new project. So I'm going to connect to the same database. Fortunately, I know Michael's password. I'm also going to connect to the same repository as well. I'm using Subversion. As I mentioned at the beginning, currently the product supports Subversion or Team Foundation Server. I want to connect to that schema that we've just seen in SQL Developer, so widget Michael schema. I'm going to connect to the same folder that I was checking changes into a minute ago. We've got a quick summary here. So again, Oracle database. This time the widget Michael schema maps to the widget folder in my Subversion repository. Let's create the project. So very quick and easy to actually connect your database to source control. And we can see here that we've got a different message. It actually says got 15 changes to get. We're looking at back in the history. Before I set the demonstration up, I checked some changes in. I obviously checked the new ones in as well. And these are the new objects. Of course, Michael can review all of these beforehand, but he's pretty confident these are okay. So what we're going to do now is apply the selected changes to the database. So let's go back into SQL Developer. Let's refresh these, and as you can see, this schema is now populated. The great thing about this though, this schema is populated with the objects from Subversion. So we can be pretty confident that these, if everybody has been sticking to what they should be doing, and that's source control and database code as they go along, this should be the latest version and the most up-to-date version, or the version, I guess, that we're happy with that's in source control. Now Michael can carry on working. So I'm going to run this next script. Source control for Oracle will pick up that there has been some changes made. This one put changes into the original project. So let's quickly go back in here. Let's check these changes in. And what you should see is that if we refresh Michael's project, it says 2 changes to get. They're the 2 changes that I've just checked in. And in the same way, Michael can open the project up, review these, and decide whether to apply the selected changes to his database, of course, once he's reviewed the side-by-side difference. So I hope that gave you a quick insight into what source control for Oracle does and how it can help you whether you're working in a shared or a sandbox environment. So as a recap, source control for Oracle enables easy database source control with SVN and TFS. It avoids some of the errors that can be associated with manual processes, enables you to very easily see where differences lie, and of course it does all of the hard work in terms of converting database objects into files for you. It's a standalone application, so whichever SQL editor you're using, if your team's using different SQL editors, then you can carry on using those as you normally would. If you're looking to move to working with more sandbox development environments, then Source Control for Oracle can also be used to help you set these up. As I showed in the diagram, the next stage would be deploying those changes from Source Control to your testing environment. Our schema compare for Oracle product can compare databases to database. It can also compare databases to these folders of script files that Source Control for Oracle creates. So it's an integral part of Redgate's deployment suite for Oracle. All of our tools can be downloaded for free at redgate.com/Oracle. To download a free 28-day trial of Source Control for Oracle, simply go to redgate.com/Source Control for Oracle. So I hope that gave you a good insight into the tool. If you have any questions, please do type them into your question panel now. Okay, so we've got one question that's come in, and this is to do with the ebook giveaway that I mentioned. So let's quickly, I can scroll back to the beginning of this presentation. It wasn't too far away. And if you're interested in this ebook, it's a really nice, concise guide to getting the best out of Tortoise SVN and Subversion. It does include a chapter on source control in Oracle, which obviously features source control for Oracle. So you can download this ebook at redgate.com/Oracle-SVN-ebook. So no further questions have come in. Please do check out Source Control for Oracle at redgate.com/Oracle. If you do have any questions, please do reply to the email that I'll send you as a follow-up to this webinar, or connect with me on Twitter at allthingsoracle. So thank you again, everybody, for attending, and I hope you enjoy the rest of your day or your evening, wherever you are in the world, and I look forward to talking to you again at the next webinar. Thank you.